In this video, I'm going to show you how modern supply chain attacks, open source supply chain attacks, are not being detected by modern EDRs. We'll use as an example, but it's something that is wider and touching the entire market of EDRs, including Windows Defender. So we're going to publish an NPM package, but to publish an NPM package, we need to create an NPM account. We'll walk through the process. We'll go to the sign up. Okay, so they just send me to this email address one-time password. But other than verifying you are having an email address, this is what you need to create an account. Next thing, we're going to use this cetemp directory to create a new package. So let's open a terminal in this path. I'll make a directory. This is the name of our package, and we are going to use the command npm init, initialize a new package. So this is our package name, initial version, description. We'll keep everything blank at the moment. And that command created this file inside. This is the manifest of our package. It says this is the package name, the package version. Basically everything is blank, but there are a couple of extensions like dependencies which is currently not defined. We can publish this to this newly created account using, we need to log in our terminal, so we need to do npm plugin. This command asks for our username, so we are going to use this username and provide a password. Email address is not need to be real, so we can use whatever we want. It's just for display. And they sent me another one-time password. Alright, I'm logged in. What I can do now is use npm publish. This command is reading the package's manifest, and if the name is not occupied and available for occupation by this user account, it's going to take it and publish this version underneath it. So let's try our best, and it appears to be available, and we just created this new package. So we can go and copy this name and go to this page, and published a few seconds ago by our user account scsbot002, and this is the initial version. We don't have any code inside. Now let's create another directory to simulate an application or consumer of this newly created published package. So we'll open another terminal here. Pay attention to the path. My app is for my consumer simulation, and this terminal is focused on when we publish the changes on our package. Awesome. So what I want to do here is npm init, not to publish the package, but just to create in this directory the package.json file to add dependencies. And what I want to do here is I want to install using the npm install command this package. So what I want to show you that happened is we installed this package, and this dependency is also stated in this package in my app's manifest file dependency section, and was fetched and deployed, currently without any code, to this node modules directory. So far so good, as expected. Let's make things more interesting. I want that anytime someone installs this package, something would be executed silently. So let's edit these files. And what we can do here, in the script section, there is a built-in option called post install, which going to execute the bash command provided upon every new installation. So if I'm stating here post install, I can write any command here. I want to introduce a new file to this package. Let's call it main index.js. And I want this script, whenever executed, to create a file on the user's desktop with the timestamp. Now I have pre-made this, so I'm going to copy it and paste it over here. This is 8 lines of code, very simple. It basically samples the date and time, creates a new file on the user's desktop, and the content is also included with the date and time. So this is it. So our post install is going to be, once we added this to our project node, and as an argument to node interpreter, index.js, and this is going to be executed on every new installation, and we need to promote the version because we can't publish what we already published. So we need to increase the version with any value we want. Let's do it by 1. Sweet. Now, again, as we did before, let's call the npm publish command. Now we're going to see here it now saying 1.0.1. This is the version published. We'll wait a few moments, and here what we can do, npm install, and stating explicitly this new version. So you see this file was just created. The hour is a bit offsetted because it uses UTC, but it doesn't matter. You see this code is executing in the background. This introduces obviously some risks and threats to integrity and security of such packages, but this is by design. You can execute commands upon installation. This is what happens by default. Okay, so let's take it one step further and use this index.js JavaScript file to do something else. So let's take the exact same logic that creates files on the user's desktop. Let's copy it. And let's use pastebin. As I'm sure you're aware of this website and how attackers using it to share some payloads. So we just simply paste the small JavaScript command code as is, and just create a new paste. We'll use this raw URL and copy it. Now, instead of what was stated here, I'm going to delete it. And let me show you how attackers use using a stager techniques to fetch code from another resource and execute it in the victim's runtime. So this is all you need. But we'll need an HTTP library as a dependency. This is a very legitimate library, a very popular one. So we're going to utilize it to go out to this URL. We're going to copy it to our script. And what this is doing, it's fetching this result and using the built-in eval command, which is evaluating string as code, injecting it into the runtime, and just as it was included. Very simple yet effective. So we're going to hard code this pastebin URL, save it. We are going to add Axios as a dependency of our package. So this is done by npm install Axios. You're going to see as it's installing, you're going to see this file is modified. And updated with this dependency. Again, as before, we're going to increment our version number and then npm publish. Back to our other terminal, simulating the consumer. And let me show you the desktop. I want to show you that it's still working. So we'll clear out this file. npm install. The new version is 1.0.2. You see, it still worked. We just added another stage. So this new stage is working as you see here. And at this point, I would consider it suspicious. It's not doing something malicious, but it's not best practice. It's not common to see legitimate packages fetching their code dynamically and evaluating it, injecting it into your runtime. So this is something I would avoid, such behaviors of packages. But I couldn't say if I would bump into something like this. I'm 100% sure that this is malicious. Again, you see it's running in the background. It's saying I'm secured. We can try and force to scan this both of these directories, scan for threats. So this scan was completed. Nothing malicious found. I'm secured, as the EDR says. Okay, let's move on. Let's take it to the next level. So we used a pastebin stager. Now, a lot of developers are setting up their environment with secrets or tokens to work with services such as AWS, GitHub, um, other production services, environment variables. It's something that happens, and whenever we ask developers to do all kind of two-factor authentications and all kind of procedures, at the end they set up their environment with secrets that allows them to work transparently. So whenever they open the terminal, as I did just right now, I logged in once to npm, and this login token is somewhere stored on my computer. So even they forced me to do a one-time password thing, but I can do multiple publications and doesn't ask me once I'm having an active session and this token is stored. They don't ask me for this repeatedly one-time password. And this is by design to not create friction among developers, to allow them to work and to progress fast without stopping. So some tokens expire after days, weeks, some are not. A lot of DevOps engineers, systems engineers, software engineers in general using SSH keys. SSH keys are using to authenticate to services like GitHub or to AWS servers or other cloud provider servers. So what I want to do now, I don't have SSH keys on this machine, by the way. This is blank. But let's use the SSH keygen command. It's going to create an SSH key. And I'm going to upgrade the payload we're going to download and execute from our pastebin stager. And this payload is going to exfiltrate. It's going to send out whatever SSH key exists here to legitimate service. To do that, I'm going to use the SSH keygen command, and it's going to generate a public private key pair. This is the default path, by the way. The user profile directory .ssh IDRSA. So that created two files. I'm interested in the private key. This is how it looks like. Don't worry, I'm going to delete it after this video. I'm not going to use it, but it's not uncommon. This is going to be populated with multiple production keys, and this is something we see threat actors are very, very interested in. Moving on, our target here is to read this file and to send it over. Let's use GitHub to send this private repository. So GitHub is a legitimate service. This is one of my anonymous test user accounts. So I can create a repository over here. So let's create a new private repository. Let's call it my collection. We create this repository. To access this repository, I need to create a GitHub personal access token. So under developer settings in this GitHub profile, I can create a new token. Let's reduce it. I'm going to delete it anyway. To this newly created repository with permission to make changes. Content. Read and write of our content. We'll generate this token. It's going to be presented here. So this is now copied. So back to our packages. this is going to remain. We're going to change this paste bin URL, but this is going to remain. And the code we want to do, it's this exfiltrate to GitHub short code. Basically, this is need to be filled with my GitHub token, my GitHub user account, repository, and what this code is doing is sampling the timestamp, is reading the file under .ssh on the user's home directory. IDRSA is the file name, reading it, and simply using GitHub's API. I'm betting you're not blocking this API in your organization, development, either production, because some dependencies are using this API to fetch additional precompiled components. And this is just going to commit using this API, this new file, and authorize using this token. Very, very simple. We're going to copy it. What I'm doing right now, it's a bad practice, but this is purposely done and knowingly done. I'm not supposed to publish this token on Pastebin because someone is going to exploit it, but this is a blank account just for this demonstration, just to simplify it. So I'm anyway going to revoke this token. So don't do it if you're going to try it out. So I'm going to create another paste. And by the way, I can use any resource other than Pastebin, even GitHub, public GitHub gist or resource as an alternative to Pastebin in case you're preventing access to Pastebin. So we'll create a new paste, add this code with our secrets and instructions, create this new paste, copy the raw, and now we're expecting to see once the code is executed, we're going to see some files created here. We need to fetch in our index.js, instead of the old paste, which is creating files on our desktop, this is the URL. So this is the new URL, this is the old one. I'm going to delete this. Code remains the same. We're going to increment the version of our package and again npm publish. Okay, now I haven't executed this yet, so we're going to install this updated the version of our package, and while we do that, I'm going to hit refresh over here, and voila, this is a new file uploaded from my stager script. As you may guess, it is matching let's see if I can find it. Yeah, it is the same private key. Again, not detected by EDRs. Once we added a new stager, this is something that they are not able to analyze. Even static analysis tools, this is their Achilles heel. They can't get this dynamic context. So we created a deeper concept of analysis. We include both static and dynamic analysis, detonation of such malware, and we monitor the runtime behavior of what happens in a contained environment. So when we see such activity, some bait files being exfiltrated, this is something we know this is bad behavior, especially when there are sensitive files involved. At this point, I can finish and tell you this is the proof of concept of how EDRs are not designed to deal with such threats. Let's publish the final example of our package to exfiltrate data, not to GitHub, but to Discord webhook. Discord is a chat application very similar to Slack, highly popular. All you need is an email account and you can create a user. The concept of servers are like channels or organizations similar to Slack. So you can create a server for private server, let's call it EDR demo. And it's ridiculously simple to create integrations. So if I want a bot, a software, something to send data to this area, this channel, what I can do is going to the server settings, under integrations, webhooks. They created this default webhook, which is basically I can change the name, change whatever I want, but they generate a unique URL. This URL I just copied. It binds to this identity in the settings, and every new message published using this webhook is going to be placed here. So this is a code example to exfiltrate to Discord webhook. So what I'm going to do here is replace this placeholder with our webhook address, this long text. Same code, but it's going to adapt it to this Discord API. It's going to attach a file to a message, and it's going to read the exact same file. So let's copy it, go again to paste bin, create a new paste, and click raw. We're going to change the paste URL to this. Okay. So we just installed 1.0.6, and this is our exfiltrated webhook sending us our private key from our victim's machine. So this is just yet another proof. I'll scan it again. If you don't believe me, this is not detected by EDRs. But as far as it goes for them, it's just regular code going out to a URL, evaluating, nothing malicious. You know what? Even the samples in this are not detected. So pretty much this is it. Thank you.